Hey guys, Mrs. Traeger here. Today we're going to talk about correlation and having to do with lines of best fit. Our learning target is you'll be able to estimate and interpret correlation from a scatter plot, and you know you'll be successful when you can match scatter plots to their correlation, and you understand that correlation does not equal causation. Let's jump in. Here is a problem that you've seen a bunch of times before, another slope problem. Let's jump in. We've got, let's see, rise of a run, so I'm going to do 19 minus 3. And on the run part, 17 minus 19. 19 minus 3 is 16, and 17 minus 19 is negative 2. 16 divided by negative 2 is negative 8. There's my slope. Hopefully you're getting really good at these. Today's lesson is about correlation. The correlation R is a measure of the strength and direction of a linear relationship between two variables. It's between -1 and +1. The picture that you see here is a correlation that would be positive, seeing how it's going up. We've talked before about direction being positive or negative. From there, it could be any number between 0 and 1 or 0 and -1. The closer it gets to 1, the closer the points are to the line. The closer it gets to 0, the further away the points are from the line. In this situation, I can see the points are relatively close to the line. So I would say that it's positive since it's going up. And since they're relatively close to the line, I could estimate that this was maybe a correlation R of about 0.8. Since they're close, but they're not perfectly on the line, that would be a 1. Here's a picture of a bunch of different correlations. So you can see this one is going down, so it's negative. This one's going down, so it's negative. Going down, negative for each of these, so each of them are negative. That's the first thing I want you to notice. The next thing is that all of these ones are going up, so it's positive, going up, so it's positive, and going up, so it's positive. Lastly, I want to look at the actual numbers in play. This one was really close, so it was really close to -1. This one was relatively close, so about 2/3 of the way close there, and about 1/3 close. Same thing with the positives. Lastly, there's this situation where the numbers are all over the scatter plot. There is no correlation up or down, so it has a 0 R coefficient. Let's play the guessing game. Here is a plot, and there's 25 points on this plot. I would like to take a guess as what we think the correlation coefficient is. For R in this case, I'm going to say it's pretty darn close to 1. I know it's +1 since it's going up, and it's really close to 1. My guess is 0.8. Let's see how close we were. 0.995. I needed to get better. Okay, so this was really close to 1. Here's another one. These points are kind of all over the place. They're kind of going up, but not by much. So I guess I would say a positive number, but it's pretty close to 0. Maybe 0.1. Let's see. 0.3. Okay, fair enough. I was pretty close. Here's the next one. Again, I kind of feel like they're going up, so positive. A little bit closer than last time, maybe 0.4 on this one. 0.5, okay. Here's my last one. These ones are going down. They're relatively close together. So I know it's going to be negative, closer to -1 than to 0, maybe -0.8. Hey, I was dead on. I'm getting better. The next thing I want to look at here is called correlation versus causation. So here is a correlation that I want you to notice. In red graphed is the age of Miss America. You can see in 1999, Miss America was a little bit over 23 years old. And then later in 2009, Miss America was about 22. Then in black is murders by steam, hot vapor, and hot objects. You can see these two lines seem to kind of mimic each other. So the issue is sometimes we notice that if something correlates, meaning matches, then maybe they affect each other. The thing is, these things don't. Age of Miss America and murders by steam, hot vapors, and hot objects definitely have nothing to do with each other. They just happen to coincidentally be similar. So these are not causations of each other, they just happen to correlate. Here's another one. In red, you'll see the per capita cheese consumption. So you can see that it's cheese consumed by year. And then in black, you can see with the x-axis, with the y-axis on the right, you've got number of people who died by becoming tangled in their bed sheets, which weirdly is going up. Anyways, these two graphs seem to correlate, seeing how their lines match up. However, these two things definitely don't have to do with each other. You don't want to say necessarily that the more cheese you eat, the more likely you are to get tangled and die in your bed sheets. Those things have nothing to do with each other. So my point here is, though they correlate, they don't necessarily cause each other. That's all I've got for today's lesson, guys. We were looking at correlation coefficient. The biggest slide of today's lesson was right here to notice the different types of R. So if you want to pause and review anything, this is it. This is our last lesson of Chapter 6 for Algebra 1 and CPM. I will see you next time. Bye, guys.